Can you guys see me?
Yes, Karthik, it is fine.
Thank you. So good afternoon, good evening, good morning, everyone. Welcome to this new session for cybersecurity internship program. Today, we'll be talking about a very important topic. This is passwords and how do we secure passwords, right? So if there's a time permit, we'll see some other topics if it is anyone is interested in that. But I think this is going to be a very good topic today. You learn a lot about it, what happens in the background, when you're auditing or when you're working on your application, what is that you're supposed to be doing out there. All those things will come into play. It is not only from, this plays a very important role. Recently, I have been involved with a lot of, ISO audit, compliance audit for a lot of places, a lot of companies. Uh, and compliance has become quite a bit of standard these days. Everyone needs to be ISO 27K compliant for their organizations. And a lot more people are working towards it. One of the main things that they are going to look into the process is that how do you manage passwords in your application, right? When you're talking about operating systems and things, there's a lot of process, right? So you might be dealing with about what is the password character length and things and all. But there are a lot of other things also where that is very much important that happens in the background that we usually don't know about. And one of the main things when I'm checking or pen testing applications or auditing, security auditing their applications, we see is that password policy is one of the places where it is not a good way to go about it, right? They're not doing it. And the reason why these organizations are not doing this is not because they're lazy or they're bad or anything. They're not incompetent or anything. It is just that they're not aware, okay, this is the scenario, and this is what needs to be done. Okay. Uh, when we talk about password security, we're not only talking about hackers that are there, right? They will try to get hands on a few. We should also think about state actors as well. State actors meaning the country-backed hacking groups, where every country nowadays will have their own hacking groups where they try to hack into the other countries' secret things and things. That is the process of it, right? Understand one thing before we go further down today, go to password security. Password alone, whatever the security, whatever we talk about, that is the very bare minimum things that you have to do. Along with that, that is itself should not be a option for that. We should always have a multi-factor authentication enabled before dealing with the process, right? So depending on the scenario, we have to always design out there. Okay. So before any further ado, so let's dive into that, right? So before we could secure passwords, first and most important thing that we have to look into is what is a password, right? So a password is a secret string of characters, letter, numbers, symbols used to verify person's identity and grant access to system accounts and data, right? And it acts as the first line of defense in protecting information from unauthorized access, right? One of the first and foremost, whatever you do, whenever you create any website, you create a user, first thing they ask you is to create a password for that, right? There's a lot of things that goes into making this, very much important out there. And strong passwords are usually long, unique, and hard to guess, right? Strong passwords are usually unique, long, and hard to guess. So if you might have seen recently in the WhatsApp groups, I posted one option out there where if it is about 4 character, only number password, any system can break it instantly. Why? Because if there's only 4 character, maximum number of possibilities are 0000 and 0 to 9. So there are 10,000 possibilities, right? As things keeps on going, an 8 character password is also not secure, right? Wherever in your organization, they'll tell every 30 days, change password. Why is that? Why do you need to change password every 30 days? The reason being is that there is it is possible to break someone's 8-character password in around 45 days time. I'm talking, this is some old numbers, I don't know new. We'll see things today, what it will make it much more better. This is talking about old data. So if your password can be cracked in 45 days, if you change password in 30 days, by the time your password is cracked, you would have got a new password and they will need another password 40, 35, 45 days, and you keep on changing the password after. All right. And this is going to work as long as all your 30-day passwords are going to be unique. It's not repeated and it is not following a particular parameter. Right. What do you mean by a particular parameter? I've seen people do like this. From January, it is going to be like this. Feb, their password is going to be like this. For March, that is going to be like this, right? This will qualify all the parameters. There's one uppercase, one lowercase, one number, and one special symbol, special character, right? So now after 45 days, I've done it and I saw Jan 2 at 2025, mid of February. I know what is this month password. In 1 or 2 attempts, I should be able to crack it, right? So these are all those issues that is going to be there. So our goal is to increase this number of days, and there are a lot of other things that will come into place. Right? That is going to be, then. And one of the problems, why do you think, your credit card PIN is always 4 numbers and password is always 8-character? Why don't they recommend a 9-character password? If you see the password recommendations, always going to be 8-character, 12-character, 16-character, 20-character, or 24-character, right? So for normal user, they prefer 8-character. For admin or super admin, 6 to 22 character is going to be there. So why is that? And why is your credit card PIN only 4 number? Right? So this is basically, there's something called as ease of use and secure, right? I can have a credit card number with 20 PIN size, right? It will be very secure, not able to break. But the problem is we always need to find, it can be very difficult to use. Initially, they tried out with 5 and 6-character password PIN numbers for credit card. They soon found out that was not working. The main reason is it is not that the 5 is 6 is not less secure than 4. It is actually, in fact, more secure because number of possible passwords are more. What's the problem was people started forgetting the PIN number. So they used to keep a chit in the purse along with the credit card. Now, if the card is stolen, right, the PIN number is along with them, right? This becomes an issue. It does not provide the security supposed to provide because it becomes difficult to use. So they went back to 4, and that is one of the reasons like tap, wireless, card payment came into play because it makes it a bit more difficult. Right? And we have seen nowadays people are able to bypass even that. In a similar way, password is always 8-character for the exact same reason. It is very difficult for someone to remember, right? Which is 8-character, more than 8-character long. It's not going to be easy for them. So that is the main point of it. For administrator, they have to find a way, right? But the reason is that people are finding words to make the, for me, I try to use a 20-character long password. But you might be thinking, how do you think about a word that is 20 character and things like that? And I tell you should not think about a word. You should think about a sentence, right? Because sentences are easy to remember, right? You can just give, this is a wonderful day at 2:25, right? And this covers a lot, and it is, I'll tell you one thing, this will take 1,000,000 years to break, more than that. Right, so it's not going to be broken up that easily. The brute forcing process I'm talking about, right? There's a process, what we call it, there's a brute forcing. It's going to take a lot of time. So now, so I told something called as a brute force, right? What do you mean by brute force? That is something which is important to remember. Brute force is, so let's say you're having a credit card, right? You're having a credit card and credit card is having 4-digit pin, right? 4-digit pin is there. So possibility is 00009999. Okay. So let's assume no card lock is option is there, right? That has been disabled. I can try any number of attempts. So what is the worst case scenario for me to break a password here? I can take out what is the pin number maximum. First, I'm going to try 000. Then I'm going to try 001. I'm going to try 002, 003. And I keep on going all the way up to 9,999. I just need 10,000 attempts to break. Okay, via brute force, right? So if you remember, wherever they will tell you it will take 45 days or anything, this brute force process is happening out there, right? So these are all done with very specified, dedicated hardware. Okay, so you might have seen, right? A lot of places, graphics cards are more important for breaking passwords than you think. There are certain rigs will have about 12 or 8 graphics cards, that is about 5019, and I think this one is about $3,000 approximately, right? And even more in some places, or some places you'll get it for lesser price, right? 5090. And this is about, they will have 12 or 18 of them, right? These are all expensive rigs that can be used and can be used for breaking passwords. So that is how the process of breaking the password comes into play. Okay. So now brute force is not going to be, it's going to be difficult, right? Many of the reason is that whenever you log into any websites after 3 attempts, what is going to, it's going to lock the user. And this is not going to be useful in your real-time scenario, right? How can you do? Because when you do 8-character long password, okay, with only numbers and characters, okay, no special characters, okay, only number, upper and lower case letter, all different possibilities will be so big that it will take about 4 TB of text file. A text file is going to be there. In some time, I'm going to show you a 4 million one file is there, which contains about 4 million passwords, most commonly used passwords, 14 million passwords, sorry. Similarly, think about, it's not a big size. Think about 4 terabyte of it is going to be there that you are not going to cover it up. Right? So now, how do I gain access or how do I know password? Right? There's when you, I think probably in our previous sessions, in the older sessions, we're talking about session hijacking. Okay, session hijacking we have done, but that is not, we are going to talk about it, right? So what my goal here is that this is your server, right? And this is your database where your password is stored. And I want to hack into this database. Okay, that's the point of it. They can do it multiple ways. Either it could be via web shell, it could be via SSH brute force attack, or a lot of other things you can do, right? So that's how it's going to work. But before doing this, before understanding this, let's see what is the authentication process in password. Okay, how is the password is going to be used by an application, and how is going to authenticate you, and how that everything goes on to play, right? So let's look into that. So initially, this is what usually occurs, right? What happens during the initial just a second. Right? During your registration page, or what you call whenever you're registering for a website, what is going to happen? You're going to create a user. When you create a user, what is going to happen? You're going to create a password as well. Okay. So that password, what is going to happen is that it is going to be stored in the database here. During the registration process, the database it is going to store out there. So next time when you log out and log in, you will go to the login page out here, right? You go to the login page and you enter your username, right? It may be an admin or anyone, and enter the password and send that information to the server out here. So what server is going to do is that it will have a table out here. The table will look something like username, user ID or username, and followed by the password that belongs to it. And this is the traditional approach I'm talking about. What usually it used to happen before and which is not a recommended approach anymore for that. Right. So now let's say my password is, I've sent the password as password itself. This password is received by the server. This is going to check whether the password that has been entered by me is actually same, right?
Sorry, Karthik.
Yes.
Are you sharing anything?
Are you not able to see the screen?
I'm not sure about if others can see. I am not being able to see the screen. I can only see your video.
Yeah, he wasn't sharing the video.
Oh, okay. Now it's fine.
So I've been working on it without that process. Oh my God. So let me start from how password authentication is working then. Can you see my screen now, right? Audio and everything is fine.
Yeah, the screen is fine now.
Just let me know next time because I always share screen. I never do. You know, I don't have any interesting face for people to watch for 2 hours. Let's see. Sorry, guys. So let's see about what usually goes on, how password is used for authenticating a user, right? So initially what happens whenever you're working, let's say you're working on a create, you're gone to a particular web page, you're going to create a user out there. And while creating the user, it will also ask you to enter the password, right? So that password, what is going to happen is that there is going to be stored in a database, right? Some form of database that is going to be there. When you see even in Linux, that database is just a file that is access granting is going to be there. In applications, it is so going to be some MySQL or something else that's going to be used out there, right? So here, let's say the username is admin and the password for that user is password itself in our case. So when I log in the next time, right? So what is going to give? I'm going to give username as password, sorry, admin, and followed by password as password. Okay. So now when the server gets this information, this has been transmitted to the server. As we can see, server gets this information. It will go check in the database. Okay. For the admin, what is the password that has been assigned. So it will check the password is actually password. And it will compare the what is been entered by the user at the moment. If both are matching, the authentication is successful. The user is granted access into the application. But let's say here, I'll change it to something else, it could be something security. This is the password I've given out there. Now it will check the database is having password as password, but what I have entered is security. Both of them does not match. It will deny the security. And this is an excellent process to go about. I think majority of us, whatever we see today, will be based on password authentication, right? Even your OTP process, even your OTP is going to work based on this pattern itself, right? One-time password you're going to get, that is going to be there. Okay. So now can you tell me what is the issue with this approach? Anyone has any idea? What is the problem with this approach? Right? And this is like predominantly how a plain text database will look where the password is stored directly like this. So what are the issues you could face out here because of that? There are multiple things that could go. One thing is, let's say, if a hacker hacks into the server, right, hacks the server, what is going to happen? He's going to have access to the database and he's able to see your information. Then he's going to compromise that information, right? So that is what is going to happen, right? So now you're directly submitting that information that is stored in the database. How is that the hacker is able to breach? One of the best ways is we do an SSH copy, break the SSH using brute force. That is also possible. It could be many other different ways you can do it, right? You can guess the password, right? If the admin is using a weak password, then still there's a lot of places where we have seen where I have audited. I can actually go and check out admin user will be the password is admin itself. Even after seeing so many people places getting breached and everything, and they'll tell we are constantly monitoring, this is not an issue and anything. So that is still breakable. It breaks quite easily. And there, if it is a web application, there are multiple ways to get into the application. Once this data server is hacked, the attacker is able to look at the database also, right? So there's multiple things. If you go newer databases, you're supposed to have a separate password for that. And in one of the organizations, what we saw, admin were the password for it. For the system, we got into the system, they had a separate database username and password. We know what was the username and password, admin and password as password, right? So they're having some issues with that. So they had given it to an intern to manage and he was finding it difficult to manage it. Remember the password every time or taking time to log in. So he gave it a very weak password so that he does not have to remember. And this is an organization. They're having about 70 virtual machines. They're running 70 different services for multiple projects. And this guy who's working on DevSecOps, right, is an intern, not an intern, but someone with a little bit less experience. But he's the one who's managing it. And this is the password is given for that. Okay, this happens in real time, even now, it's real. So once this user is able to look at the password, right, is able to completely take over the account. Is able to completely take over the account. You might think, okay, fine, this particular website got down. I don't have to worry about it unless until you think about password reuse, right? Remember, you will be having your Gmail password. How many other places you have used the password that is you have set for a Gmail or any mail server? How many places you have repeated your passwords? That is going to happen quite a lot. So now this database is also going to have my Gmail ID because that is one of the ways of a lot of companies now application websites are going to use. Ask your email ID as the username and password. Then this all I have to do is open the Gmail and give it a try. Give it a try, right? That happens a lot. That is exactly the reason. Whenever you change, probably you might have seen if you go from one state to another state, physically travel from, let's say, you're in, in Texas and you move to Chicago, or you're accessing your Gmail from a different IP. It does not allow you to do that. It asks you to re-authenticate yourself, probably send a code to your mobile, OTP asks you to do all those things because this happens in real time. Whenever there is a breach, people have used the same password, which is used for Gmail, and then to go for that part, right? It is not only one place that is been done. It has to be there, right? So you can check out, I think have I been on? I think there's one website where you can put your email ID and it will tell you whether your account was compromised or not. And if you get there a red tag and telling that these are the different websites where your email was there, email ID, password was there, where credentials are lost. That's going to be there. When companies tell they got hacked and they tell no user was information was leaked, I don't think so. They're telling the whole truth out there, right? So we'll talk about that, what exactly happens with that. So my question is, how do I overcome this situation? Right? How do I overcome this situation? Because here you remember, this database is there in a hard drive, and this hard drive is encrypted. But one system is user is compromised, encryption is not going to help you out, because that user can access whenever he requests that the OS is going to decrypt that message and give it to him. That is how it is going to be there. Disk encryption only works if your disk gets stolen. Someone steals you, physically steal your data. At that time, it is going to work. How do I overcome this situation? Right? Especially this is very much important if you are part of a DevOps team, and you should always ask your development team, how is the password managed out there? Or your threat modeling out there. Whenever they come for security features, you have to ask one of the main things that you have to ask first, because password is first line of defense. You cannot compromise with password, right? Even after whatever the security features we talk about today, still it is one of the weakest link. That is why a lot of people talk about passwordless authentication, which we did in SSH last week. But still, this plays a very important role. Right? You have to ask and we cross verify what is happening. Are you storing it in plain text or not? Right? There are a lot of other things, right? Password complexity, there's password length, other things. Those are the things we're not talking about today. We're only talking about how the password is getting stored. That is our only criteria for today. Okay. So how do I make sure this is not going to happen? Right. So to the rescue, what comes in play is right. So as I told, there are multiple other things. If database is the attacker gets all user password directly, no privacy protection. So meaning even your administrator is able to look at your passwords. All right. Think about you are in network Linux administrator and you got about 20 users created on that particular Linux system. Do you think the Linux administrators will be able to see what is the password you have set? Right? So if it is stored in a plain text, it is possible to see. Right? In Linux, that does not occur. But in applications, that definitely occur. Right? So passwords reuse danger. Since many users reuse password, attacker can access other accounts. So meaning it is quite easy. Same password is being used for others, and it can be easily used to break into that account as well. Right? But other one more thing is, if you're storing password in plain text, you will lose all compliance, right? It is a completely they will be rejected immediately, right? That is also there. And if your organization is reputation damage is going to happen if you are storing passwords in a plain text. Okay. So now I want to ask one more question before I talk about hashing out here. Do you think Google stores your password? Do you think Meta stores your password? Do you think Amazon stores your password? Right? Do you guys think it's going to happen? Anyone like to answer this? No one stores your password. Right? That is the reason when you get forgot password, they will send a reset link, but they will not give you an old password back. If they give old password back, right, it means they are storing in plain text. This is a bad idea. They should not be able to know what is your password is. If they are sending you back a password, this is your password, forgot password, this is your password, okay, no? That is going to be there. That is not going to happen. That is meaning they are storing, then everyone can in the database, it's stored in plain text. Everyone can look into that part, right? And this is going to be very, very difficult out there. Okay. So now what is the scenario? So how do we overcome the situation, right? How is that Google does not store your password, but still detect if password is right or wrong? How does they know about this? How do they go about it, right? So for this, there's something called as the solution for this was something called as an hashing, right? So hashing is a cryptographic term which came into play long time back. So it's a process of converting data like password into a fixed length of string of character using mathematical algorithms, right? And this was very much important out there. The fixed length of thing is very much important, right? Because if the length varies depending on the what is the input character, it is going to be difficult, right? The output called as hash value or digest look random and cannot be reversed back to the original data. I cannot go back. I cannot go back, right? When you encrypt a particular text, right, there's a way sometimes to decrypt it in certain ways, right? I can look at certain things. If I transform something into something else, I should be able to go back to it, irrespective of what is there. But hashing does not occur out there, right? And used for security, password storage, digital signature, and integrity check, right? That is the main component out here. So what is that? One way function, it cannot be reversed. It is going to be same output is always going to remain the same strength, right? Small changes also it is going to have a big difference, right? So let's understand what this is, right? Let's understand what we are talking about here. So let's look it from a practical perspective. So what do I mean from this part? It's very simple. The logic is very simple. So let's say I kept a file, right? 1.txt. I'll note this part. That's two and three. So I'll keep one password out. Right. Let me give the password as password itself. Okay. So what it is going to do is that it is going to convert this into some format. Right. For instance, there is an algorithm called SHA-256. Some out there. It is going to create a particular digit file. Right? It is going to convert into a particular pattern. See over here. So this is a very unique number out here that is going to be for that. So whenever there is a password, this is the number value it is going to be there. Even if there's a small change, right? Even if there's a small change, let's say I'm going to add 1D, the value is going to change significantly. See, the value is no longer the same out here. Don't think this is going to be like this. It is even, right? Let's say this hashing algorithm can also be used for checking the file integrity. And whenever you might have seen when you download any Linux or anything, whenever you go, they will give you one option on that, right? So when you try to download, you might see something like a sum out here. That is nothing but checksum. Checksum is nothing but a hashing value of it. When you download this, this is about 3.2 GB of data. In that 3.2 GB of data, there will be billions of zeros and ones. Even if 1 0 is modified to, changes to certain other value, that is 1 or anything, even a single character changes, right? Out of the 3.2 GB, even a single character somewhere out there changes, the value is going to change completely. They all, and that is going to be there. And one more thing, see the length here. The length is constant. Either it is a 3.2 GB, 1 petabyte of data. The length is always going to be, this is how it is going to be there. This is how much it is length is going to be there. So I cannot tell if I'm storing a password, whether the password is a long password or a short password. I will not be able to go for that part. Right? And this is how it goes. So now what is going to happen out here? Using the hashing value out here, I can look into this process. So what is going to do? And this is the part what we see. Right? We take the password, convert it into hash, and we'll get a value for that part. Right? And this value is going to be different for different algorithms that you have to be very important that you have to see. Right? For instance, let's say I can do the same thing. Instead of using SHA-256, I can do SHA-512. Sorry, 120, 128. Right? What's it? Yeah, SHA-SUM and 1.txt. You see, the length is different. This is a different algorithm. It's a weaker algorithm because the length is smaller out there. The SHA-256 is much more bigger, and this is going to be the. Think about in password, every time a character is added at the right side of it, it is going to make it really, really complex. Okay, it is going to make it exponentially complex out there. So now let's come back. So how do you secure the password out here? So now they came up with this logic to use the hashing algorithm. What they're going to do is, as soon as you create a password, instead of storing, they're not going to store the password, right? They're not going to store, they're going to run the hash algorithm. Okay, let's say I give the password as security. Okay, so what is going to do? They're going to run SHA-256 sum or any other encryption hashing algorithm, and they're going to give security. Okay, when you run this is going to give you a hash value, right? And this particular hash value is sent to the server, and server will store the hash value, store the hash, not the password. So meaning only time the Google will be able to see what password you have entered is when you're entering the password for the first time, when you're creating your password, right? Without knowing what password you have entered, they cannot tell the password complexity is a good quality password or a strong password or a weak password. They cannot do that part. But once that it is confirmed and sent to be stored, it is never stored actually, right? This is going to be hash, that hash value is going to be stored, and it is going to be done out there. So now how will the database will look for this? How will the database will look for this? The database will look something like this. If you remember previously, this is how the database looked, right? User ID, username, and password was stored, and anyone breaking this database will be able to look at the password, right? So now when this is broken, right, this is going to be looking like this. And can you know the difference? What is the, can anyone understand what is the password for Alice01 or Bob22? No one will be able to know this process, right? So, but you might be again thinking, okay, this is the how the password is going to be there. How will the Google verify what is my password is right or wrong? How does it know? Right? So this is where we will see, right? We'll see how the verification process works. This is where the whenever you enter the username and password for the second time for the login process, what is going to happen is that your password is taken and it is going to be hashed, right? And you will get a hash value. You'll get a hash value. That is this part, right? And this hash value is going to be taken and compared with hash value of this, right? This hash value, new hash, is compared with stored hash value. When both of them match, it means the password is correct, right? If both of them doesn't match, it means password is changed. It is not matching out there. So that is how it is done, right? So now that is the reason they cannot never give you your golden password. Your password is not stored at all. That is the reason. So now when you tell you forgot, they do their own check to get that, okay, you are the legitimate user some other way. They might send a link to the user and things. They can do a lot of things, right? Still all those things can be compromised. Password policy manage is a bigger process, right? There's multiple steps you have to do, but here we're talking about storing passwords only today. We're not going to be worried about other things. So now this is a good approach, right? So every time what is going to happen, let's say, right? So what is going to do? It is going to come back and cross, let's say you're going to do. Sorry. This is the one. So let's say you enter the password as password or security. And what is the password here? Password. Okay, let me do one thing. Let me remove this either extra. Yeah. So now when you enter new password, this is going to take that password, put it into a file, right? Into right. So now what I have to do is I'm going to check if both of them are matching or not. If both of them are not matching, right? See, now both of them are matching up there. This is how this is going to be done, right? But this is not the end of story, because now the password, even if someone breaches the network, they can never have access. They can never know what the password is, right? Because this is total gibberish and they can never know what the password is. But it does not mean that hackers are not going to stop trying it. And this was fairly broken quite easily out there, right? One of the reasons hash value 256 is done for a specific reason of that. And the hash value number of attempts they can do is going to be very easy, right? Think about a graphics card rig that is used for breaking passwords. I'm talking about, it's about the data maybe about 3 to 4 years back. How many you think hash they can break in a second? They can break 4 billion hash in a second, right? SHA-256, if it is there, it will take a long time to break. Okay, but how do I brute force this attack? How do I compromise this approach of that? Now it is no longer simple, right? I cannot, we are increase the complexity of the attack, right? It is not that it cannot be broken or anything. It still can be broken out. Correct? It still can be broken out there, but how do I break it? Any idea how can we compromise this hashing algorithm? So here, even though it provides some kind of a security, this is going to be very difficult to secure against. I'll tell you what, because if I do this, this is not going to be very difficult. It's not going to be easy. People are going to always going to use a 8-character length password, right? We need 12 or 16 to get a good clear picture of how to do it. And I'll show you one more thing out here. In Kali Linux, by default, you will get something called That's it. Right. There's something called the rocky.txt. This is the text file. This text file contains rainbow data. So meaning what I mean to say is this is having about 14 million, 14.3 roughly million most commonly used passwords. Right. So it is going to take time for it to just to open also. Right. And see, this is not a big file. It is only 133 MB and it contains about, 14 million passwords. Think about if I try all the variations, it is 4 terabyte. Think about how many passwords that will be there. Right? It's going to be very, very difficult. But so now, but this is quite going to be a lot of people are going to be using common passwords out there. It's not going to be difficult. So how do I go? How do I use this part? Right? How do I use this? Break password. Right? So let's say show you catch. So it's still going to take a long time to show all this stuff. So what it is going to do is, let's say hit -in1 rocky.txt. It is going to take the first password. Right. It is going to take 1, 2, 3, 4, 5, 6. It is going to do a SHA-256 and it's going to get a hash. Right. And it will check this hash value with the one that has been compromised. Okay. Is both the hash same? No. And it will keep on going up there. It will keep on going on. Then let's say somewhere down the line, there's password add 1, 2, 3 is the password. You will get onto this and SHA-256 will be done. The hash value will be received and it will match exactly out there. So now the hacker knows that the password is actually password at 1, 2, 3. So here there's using a brute force, but they're using rainbow tables. The list. So whenever there's a file that contains most common name passwords, it's called rainbow table. Right. The main reason is I'm not doing a incremental password breaking brute force. I'm not doing it. I'm doing the reducing the number of attempts out there by guessing what could be the list of passwords. So even though here it is 14 million, it is a very low number of them. Right. It is a very low number that a lot of people use, right? Still, there's a lot of people who are using 1, 2, 3, 4, 5, 6. So let's come back. Let's do this again one more time, right? Let's do this again one more time. So let's say there is a database, right, which is stored in a server. And this database contains user ID, username, and hash of that particular password. So let's say I'll give it this, and the username is going to be root, right? For the sake of example, for practice purpose, I'm not going to write a big one. Let me write 1, 2, 3, 4 is the part. So let's assume this database got hacked. Okay, and the hacker is having this table out there with him, but he can't do anything about this table because he cannot read the hash of it. Right? He does not know how to do it. But remember, this is the hash value for the password is pass at 1, 2, 3. Right? This is the password. So hacker does not know that this is the password for that. But he wants to identify what is the password for the root, because once he's able to do that, he can get inside the application and he can do anything. Why? Because this is the super admin user. How do I do that part? So now he's having, let's say he's having, for the sake of argument, okay, this is going to be a rocky.txt. This was only containing 5 passwords for the sake of example. In reality, it will be having a millions of passwords. So sometimes even a billion. So the first password is pass. Second one is password. Third one is password at 1, right? Then it is going to be security, right? And then it's going to be pass at 1, 2, 3. Okay, this is going to be important. So now hacker is going to do, he got the hash value 1, 2, 3, 4. So he's going to take this first entry in here, that is pass. Then it is going to convert into hash algorithm. And what he's going to get is going to get 9999, which is matching this. No, it is not matching. He knows this is not the password out here. Same thing is going to do that for password as well, and then he's going to, then he's going to, let's say 8888. It is not matching. This is not the password. Same way he'll keep on trying each and every, and finally he'll come to the pass at 1, 2, 3. When you convert to hash, the value is going to be 1, 2, 3, 4. Both of them are matching. He knows the password is 1, 2, 3. And this is how it goes, right? This is how it goes, and this is very important criteria that you have to be very careful about, right? So even though that is going to be there, it is still possible to break, right? And it is not that there are 100 users, right? There are 100 users, and I have to keep on trying 14 million tries for all users, right? It is going to be not going to be that. Why? Lot of users may be using the same password, right? Let's say admin root user is having 1, 2, 3, 4. There's one more user called John. We see that his hash value is also 1, 2, 3, 4. So based on this, I can tell even John is using a same password. So this is going to be very easy, right? So all I have to do is that I have to create one database, right? One database where I'll contain all 14 million passwords, known passwords I'm having, and generate a hash value for that in my free time. Probably it will take 2 days, 3 days to create all those things, depending on your system. If it is very fast, probably it'll take only a couple of minutes for that, right? I'll create the hash value. When I got the new hash value out there, I just have to plug it in the database and search. Then I'll get the corresponding password for that. Now this becomes a bit difficult, right? So because hashing came into play when computational resource was very, very small. Okay, it is, think about the advancement in computation has been so significant. When NASA sent in the Apollo mission to the moon, initially they needed a computer to navigate the rocket because it was never possible for that minute connection to be done by humans. So it has to be automatic. A computer has to do that part. So that computer was almost, size of a car engine and bigger than that problem, right? A semi-truck engine out there. That is how big it was, right? And it could only do that particular rocket alone. Fast forward today, your normal phone, normal smartphone, it's not only can do that navigate that rocket, right? It can navigate 1,000 rockets at the same time. That is how much computation is there. So the hash value breaking becomes much more easier now, right? And if the passwords are smaller, it becomes much more easier because the list is going to be small out there, right? If you're having 8-character long password, right? And if you're having only numbers and characters, you can probably go with that 4 terabyte of data very fast, right? 4 terabyte of data very fast, because think about copying. It is simple as copying the file. It might take the same amount of time, how much time it takes to copy it, right? So, and if you're having the rigs which are having a RAMs which are size of 256 at 512 GB RAM, it is going to be much more faster, right? So how do I overcome this? Hash was supposed to be the savior for this part. How do I overcome this scenario? Any ideas? Right? These are the things which we discussed right now. So how do we overcome this scenario? And especially the one problem that they wanted to solve is If identical hashes are there, it means identical passwords. How to overcome this? How do I differentiate someone's password with that part? Okay. How do I overcome this process? Right. The concept called as salting came into play. Right. The salting is a process of adding a unique random string to a password before hashing. Ensure that even if two users have the same password, their hash values will be different. Why salting is important? Prevent rainbow attack tables, right? If I'm having a pre-compiled, it is going to defeat that process of that, right? Ensure unique hash for identical passwords. If two users are having the same password, their hash value is still going to be different, right? And makes brute force dictionary attack much more harder. It is going to use the same concept for hashing out there to break, but we'll see how it will make it more difficult out there. And this is what happens in your real time as well. Right, for instance, you can see this exactly the process out here. Right, so you could see here what is happening out here. So whenever you enter a password for creating, it is going to take the password, right? Along with that, it is going to add a string. And this string is going to be random, like you can see here, AF10GH. There's no meaning for that. There's no reason. It is completely random, right? And now this is going to take that hash and store it, right? This hash is going to be there. So for instance, every user, the hash is going to change, meaning, let's say the user one password is password only, but it will add a random value to that, let's say AG19C, right? Again, for the user two, the password is still password. They're both sharing the same password, but the salt value that is random that is going to be there, BCF9G, right? Now the hash is going to remain the same for that? No, because of this changes that is there, hash is going to change completely. So that identical hash problem is going to be more difficult to break. Right? And this happens in real time. I'll show you one example is all of your Linux operating system. Whenever you create passwords out there, this is what is going to happen out there. Okay, for instance, where do you store passwords in a Linux operating system? There's a file called shadow file. It is going to be present out there. So let's say it is stored in cat etc shadow. It will display here, and you could see here, this is your hash value out here. This is your password. The password for this user is just Kali, K-A-L, like Kali. Kali is the username and password is also Kali user. Okay, so any user created, this is what is going to happen out there. There's going to be a salt value, and then again it is going to be the hash of your total value out there. Right, and this is the -y is the hashing algorithm. This is nothing but a script. That option is there. That is what it is going to be there. All right, for instance, let's say I'm going to use add user. I'm going to create a user called John, right? So add user password, it is asking. I'm going to give password as PASS only, retype password. Okay, I'm not going to enter all of this. This one is the information correct. Yes, the user is created. So if I go back to the shadow, and you can see the user is created, and along with that, hash is also going to be present out there. Let me do the same thing now for Alice. Okay, the password is going to remain exactly the same out here. Right, the password is going to be remain. I'm going to create a user as sorry, Alice, and for the password is going to be PSS, and I created it. Right, I'm going to create by. If I see here now, even the password is same, the hash value is completely different out here. Hash value is completely different out here because there's a salt added to this process. That is how it works in this process for us. Okay. So now, how do you think the validation is going to occur out here? Right? How do you think the process is going to be verified. Whether the user is entered the password correct or wrong, how does it occur? So the process here is very simple. In previously, how was the data? The user ID, right? And it stored the hash value. Was there. So now it is going to have also the salt value also with that. Usually it is not to be saved, occur. When you talk about Google and big company, they don't save the salt in the same table. It is going to be saved in a different database, sometimes not in the same network also. It's not in the same system, not different system. That different system may not be in the same network, maybe in a completely different place that is going to be there. Right? So how it is going to happen? The user is going to enter username and password. Right? Let's say the password is going to be pass at 1, 2, 3. And this, before converting this into hash, it is going to check in the database. It is going to retrieve the salt. Right? And this is going to be completely random out here. So now password at 1, 2, 3 plus the salt is going to be taken. And now a hash is calculated and then compared with the stored hash value. Right? When both of them are matching, it means everything is working fine. If they're not matching, it means it is not work out. Right? This is very, very useful out here for us. But why do you think? Why do you think? Right? Why do you think this is better than only using hash? Right? One thing is, even if the password is same, password duplication is resolved, right? Other things that is going to be there. If you remember, we told the longer the password, more secure it is going to be. Right? So let's say I'm having an 8-character password. Let's say your password is actually 8 character, right? If I have an 8-character salt, what is my password length is going to be there, right? Let's say I'll give salt 1, 2, 3, 4. My password length becomes 16 characters now. Now doing this is going to be very difficult to break. Right? Doing this is going to break. I can keep on increasing the salt value and increasing the password complexity, even when the user password that they have set up out there may be lesser. That is the reason you see in Gmail, your password complexity compared to others is going to be a bit less, right? And they have a lot of other stringent ways of connecting to it, so they can reduce make the password to be less complex can be used out there, right? That taking a lot more information out of your system. Gmail is going to take, right? They know your what model your laptops are running, what is the screen size and things, your what browser you're logged into and everything will have a fingerprint and they know exactly where it came from, right? Every single time. So it makes a little bit more sense to have less complex password to allow for that part. But that is not the case. In real-time applications will not have that kind of access or the computation resources to secure someone, right? And it will not be feasible to put that part. In that time, salting plays a very important, right? So how do you break a salt, right? So let's say password plus I told salt 1, 2, 3, 4, right? Let's say this the hash value is something like this. To make it simple, we'll talk about this. If I take my rainbow table now, the password will be there and I create a hash. If that one will not match with this part. Why? Because this is what it is missing. It is missing the salt out there. So for breaking this process, what I have to do, I have to brute force that particular salt out there. Remember, password is predictable. You have to remember something you cannot completely randomize it, but salt can be random. So here I cannot, there is no rocky.txt file for salts because there's nothing there like that. It is completely random. So even if 4 character long, I have to start with a, then again compute password with a, and keeps on going like this, right? For a single hash, calculation went up significantly. The difficulty level and the computational requirement went up significantly. And because of this, it is become very, very difficult to manage for us. Right? So that is why salt is very important. Right. So when you store salt in a different computer or a server than in a one where you're storing a password hash, it means the now hacker has to hack 2 servers to get access, and still he has to calculate a lot. Right? He has to freshly calculate a lot. I cannot have a database of SHA-256 and use it. I have to do it every time. Right? And because this alt size, it's going to be much more difficult to manage. Right? So that is the reason. That is the reason. Right? You can check it out. For instance, if you go to this website, if you have, right? If you put your password out, any email ID or anything, if it has been hacked, it will show you this. See here, it is having database from 901 hacked websites. This is the number of accounts that has been compromised, and this is not something, right? This information, the person who is working on this, I think is I think some I don't remember his name, right? Troy Hunt or someone, I think it's Troy Hunt, right? He goes online, goes to the dark web where he purchases this the data, right? Hackers, whenever they steal or hack websites or the servers, and when they get this dump of hashes with the username, they sell it in the dark web out there, and it goes on. It takes time, right, before for it to be sold for much more higher price. For instance, recently, I think one of the big companies got hacked in 2019. Their password data surfaced in 2024, right? So they were still being, they got to know they got hacked at that time. So this is how it's going to work, right? So you can enter your name at here, I don't want to give away my email ID, right? For me, it gave me that my account was compromised, meaning my password hashes were stolen. It was in LinkedIn, it was in Twitter, it was in, 500, one of the photography websites. That is going to, that is the one they're talking about. They know about, there may be, you may be, how many times you might have logged into some random website which may be having 5,000, 10,000, 2,000 users. That information is not going to be there. And what is the guarantee that they're going to use a safe password? Okay, so that is how it goes. That is how you have to keep it safe, right? You have to keep the process out there. Okay. So let's, for just for the sake of process, let's see when you're looking at this information, right? When you're looking at this information, you cannot know what is the password for this. 3 users. I think there are 4 users are there. If you remember, there's a root user as well, which I'm currently logged in. Root user will always be in the first line. That is why it is not there. And these are the 3 other users that are created. Right. So now let's say we'll try to break what could be the possible password for this using our rocky.txt file. Okay. So what I'm going to do is I'm going to take first 1,000 lines only, because if I go through all the 14 million lines, this is not going to work out. It cannot break it in this part time, right? I'm going to create a password.txt file. This contains all the most commonly used password list. Okay. For this to work, the list should contain the password. It cannot predict. Otherwise, you need algorithm where it is going to predict that part. But here we are not going to. This is a very simple concept. Okay. First and foremost, there are two files that are there. Okay. For user created process, one is ECDC pass file, right? This is going to be there. This contains certain information for us, and the shadow file which we saw, right? So we need to have those two files together, combine it. For that, there's a command called unshadow, right? First give the passwd file, then give the shadow file up there, right? And once you do that, make sure you pipe it and get the shadow.txt, right? You can name it anything. It is now. I'm just giving a name of that. Okay. Now it is combined two things. Previously in shadow file, the alias and bin folder was not there. That is been added out here, and here the hash algorithm is going to be used. And see, this is the salt value that is going to be present out there, right? So now for every we are going to use the all 1,000 passwords and then trying to break into the part. But see here, our password is not there in this. Okay, what was the password? Right, our PASS is not there. It is having other things and all. So we'll add that. We'll also add. Let's check is Kali is there. That is also not there. The root user password is store TOOR, reverse of root. That is not there. Let's add all these three things, but we are going to add it in the last. Okay, remember it has to be there, otherwise it will not be able to break it. First password is true, Kali and pass. Okay, and it is going to try to try all the combinations for all 4 users. Okay, you can see what is the comment for that. Right, so here it is very simple. This is containing the shadow file where it is going to be having all the thing, and the password list where it is there. It was there in the password.txt file. Okay. So here this contains the file that has hash value. Right. This file has all password list. It also can tell you the rainbow table as well, right. That's going to be there. And this is going to be the format for the crypt of the crypt, meaning if you see there are multiple hashing algorithms, right? SHA-256, SHA-1, 2, and 3, and things for that. So here, what is happening in Kali Linux? In Kali Linux, cat/etc shadow. You can see there's a -y. So -y stands for what? It is an algorithm that I'm using out there, right? So you can see, check it out. Kali $y. Right, so it will tell you what is the algorithm that is going to be present out there, right? What hash type is -v? It is a script. Okay, CRY crypt. This is the algorithm that is used. Okay, so that I have to specify to the tool, that is the John the Ripper tool. I have to tell which is the algorithm that has to use out there, because if I change the algorithm, it is not going to match, right? So let's press enter and see. Wait for it to check out there. See, check out. See here. Immediately I pressed enter, the CPU utilization in my virtual machine gone up significantly high. It is going through all the 1,000 different variations, right? And checking out what is the password for that. It is going to take time. Okay, so let's wait for 2 minutes out here and we'll see. Think about, because this is my virtual machine is not having any graphics card and it has a very limited CPU and RAM, so the time is there, taken is more, right? But if you have a real-time system, it's going to take it much more easier to crack this, right? Guys, yeah, you can see it was able to crack all 4 users' passwords. That hash file is going to be there, right? This is how easy it is going to be to crack. Think about 14 million thousand. We are able to do it in a couple of, I think, less than a minute. It was able to do it, right? 48 seconds probably. Uh, think about me running Kali Linux directly on my laptop with the graphics card and everything. This will be much more faster rather than running in a VM. And 14 million hashes calculation is not going to take a lot of time, even in my system. Probably it will be able to do that in 1 or 2 days time, right? Maximum, not more than that. So salt plays an important role, right? As soon as this becomes bigger, this is how it is going to take time. It is going to be not be, you know, so very, very, very difficult to break. Still the same process, but it makes it very difficult to crack, right? So that concludes our password cracking today. So anyone having any questions? Any questions, guys? So I think no one is asking. I think it's done with the session. So David, sir?
Yeah, tell me, Karthik.
The content is completed, sir.
That's fine. That's fine. Thank you. Thank you, sir.
Thanks.
Thanks a lot. So we can stop the session.
Yes, sir. So anyone is having any doubts, we'll clear. Otherwise, we can stop the session.
Okay, then we can call it a day today.
Yes.
We can wind up.
Yes. Sure.
Thank you. Thank you, everyone,
Thank you. Thank
for
you,
your
everyone.
patience and participation. Yeah.
Thank you.